Welcome to this comprehensive tutorial on implementing RSA encryption and decryption in Java. If you're interested in cryptography or data security, you're in the right place. Let's start with the basics. RSA stands for Rivis Shamir Adelman, the names of the three inventors. RSA is an asymmetric cryptographic algorithm, meaning it uses a pair of keys, a public key for encryption and a private key for decryption. In this tutorial, we will go through the following steps: generating the RSA key pair, encrypting a message using the public key, and finally, decrypting the message using the private key. Before we dive into coding, let's ensure you have JDK installed on your machine. You can check your installation by running Java version in your command line. To begin, we need to import the necessary Java libraries, java.security and javax.crypto. Let's look at the initial setup of our Java class. Now that we have our class set up, let's create a method that generates the RSA key pair. In this method, we utilize the key pair generator class to generate a key pair. The key size is set to 2048 bits for enhanced security. Next, let's create a method to encrypt our message using the public key. We'll use the cipher class to perform this encryption. In this method, we initialize the cipher instance in encryption mode using the provided public key, and then we call doFinal method passing the byte array representation of the message. After encrypting the message, we will want to create the decryption method. This will use the private key to retrieve the original message from the ciphered text. Similar to our encryption method, here we initialize the cipher instance in decryption mode. We then do the reverse process to retrieve the original message. Now that we have our core functionality, let's put everything together in the main method to demonstrate RSA encryption and decryption. Here, we first call generateKeyPair to create our public and private keys. Next, we define an original message, encrypt it using the public key, and print the encrypted message in base64 format for readability. Finally, we decrypt the message using the private key. To summarize what we've done, we first generated a key pair, then encrypted a message using the public key, and finally decrypted it back to the original message using the private key. Now, I encourage you to run this code on your machine to see the RSA encryption and decryption in action. This fundamental concept is widely used in secure communications, so mastering it is greatly beneficial. To solidify your understanding, try altering the message and experimenting with various sizes of keys. Increasing the key size can enhance security but may also impact performance. If you found this tutorial helpful, please hit the like button and subscribe for more programming tutorials. Comment below if you have any questions or specific topics you want us to cover next.